All right, so we're picking up where we left off yesterday. This is going to be day 2 of lesson 1.1. And so we're starting with question 3 on the front of the notes. Now, before we get into this, I want to discuss the difference between two really important terms we're going to be using here, the word or and the word and. We've got a symbol that we're going to use for each of these words. If we're using the word or, you're going to see a symbol like this that's called a disjunction symbol. And would be a conjunction symbol. So those are the symbols that we use for those two things. Now remember, think of or as very inclusive. Or means there are more ways for the criteria to be met. For example, if we were talking about probability, and I said, what's the probability that I draw a card from a deck that is a club or a 2? Well, if I pick the 2 of spades, that counts, right? Because it's a club or a 2, so that 2 of spades counts. Or if I pick the 3 of clubs, that counts too, because although it's not a 2, it is a club. So or means anything from column A or anything from column B, or anything that's both column A and column B. For example, the 2 of spades, that would be fine too. That's a 2 or it's a spade, so that would count as well. If I were to use and if I said, what's the probability that I draw a card from a deck that is a 2 and a spade? Well, now there's only one possibility. There's only one card in that deck that's both a 2 and a spade. So and is very exclusive and or is very inclusive, leaving you with a lot of options. So you'll notice in question 3, you see that we are using the or symbol. That's what that guy right there means. So we're probably going to have a lot of items that meet the criteria, or a lot of numbers that meet the final criteria in our solution set. We've got 2 inequalities that are connected with this or. So we've got the first inequality, which we're going to have to solve. And then we've also got this second inequality, which we have to solve. And the question is, where are all of the values that satisfy this inequality or satisfy this inequality? So we'll solve them independently, and then we'll give the set of values that satisfies either one of them. So the first inequality, we'll solve these pretty quickly. I'll just add 1 to both sides and then divide by 2. Now there is a negative involved here, but I'm not dividing by the negative, so the sign isn't going to switch, right? That negative 6, that's being divided by a positive 2, so I don't need to flip the sign. In the inequality on the right, I'm going to subtract 1 from both sides. And then I have to divide by a negative. So here I am dividing by a negative value to get x is greater than 4. So my solution is any value where x is less than negative 3 or where x is greater than 4. And to show what this means on a number line, I think would be more helpful here. So here's our number line. All right, I've got a negative 3 down here. It's much smaller than 4. Of course, there are a whole bunch of numbers in between, but I'm not really worried about making a fully to scale number line at this point, just trying to show where my solution space is. Now the first inequality says all of the values when x is less than negative 3. So open circle to the left. The second inequality says all the values when x is greater than 4. So what this means is if I wanted to pick a value that satisfies this disjunction, I could pick any number that's down here or up here. Any of those would satisfy the disjunction. So, for example, 5. 5 works. Because although 5 does not satisfy this inequality, it does satisfy this one. So 5 is a solution to this entire statement. And negative 7, that would work too, because negative 7 does not satisfy the second inequality, but it does satisfy the first inequality. The other way that I can write this out is in interval notation. So I would say my solution is all of the values from down here all the way up to 3, but not or negative 3, but not including negative 3, and then all the values from 4 that direction. So these values, now how do I say that? Well, I would say starting from negative infinity all the way up to negative 3, and I'm going to use parentheses because I don't want to include either of those values. I would use a bracket if I wanted to include the number negative 3. Or 4 to infinity. So this is another way that I could write the solution to this inequality. So we've got sort of three ways here. We can leave it in inequality notation, we can leave it in interval notation, and we can graph it. So let's go ahead and do the same thing to number 4. So here we've got 4 is less than or equal to 2x minus 6. Now notice, this is an inequality all by itself. But we've got another inequality here as well. Simultaneously, 2x minus 6 has to be less than 8. So we have two things happening here, which means we've got a 4 has to be less than 2x minus 6, and at the same time, that 2x minus 6 has to be less than 8. And it's often a good time, or a good idea, to separate these two things to make the math a little bit easier to work with, right? Because now it's just like the previous problem. I'm going to solve the first inequality, solve the second inequality, and then I can represent my solution on a number line. So when I solve for the first inequality, I'm going to have to add 6 to both sides, divide by 2. There were no negatives involved when I divided, so I end up with x has to be greater than or equal to 5. With my second inequality, add 6 to both sides, divide by 2. X has to be less than 7. This is an AND situation. So this is much more exclusive. Now when I pick a value that satisfies this, I have to pick numbers that are both greater than or equal to 5 and also less than 7. So much more restrictive. If I make a number line here and I put 5 and 7 on it, well, I have to take any number that's greater than or equal to 5, but at the same time, they need to be less than 7. So this is where I will find my solutions, between 5 and 7, not including 7, but you may include 5. And if I were to use interval notation here, I would say all the numbers from 5 to 7 can't include 7, but I can include 5. So that's one way to represent your solution. That's one way to represent your solution. And of course, the graph is another way to represent your solution. Might be a good time to make a note that when we are using interval notation, brackets mean or equal to, and parentheses just mean less than or greater than. All right, so this is me just showing that the brackets mean or equal to, and the parentheses just mean greater than or less than. Now it's time to get over to the practice problems. Like the last lesson, we're not going to do them all. I'll pick 2 of these 4 to do. You can see these are the 6 from yesterday. They're all completed. Hopefully that's what your notes look like as well. So let's go ahead and do a couple of these. All right, we're going to go ahead and do the second one here, and we will do the third one. I'm going to change the third one actually to be a conjunction instead of a disjunction. Just changing up that problem a little bit. So when we do number 2 here, we're going to solve these individually. They're going to be pretty quick. Your homework problems will start off this way, and then you'll have some more challenging ones. So when I solve the inequality on the left, I'm going to add 4 to both sides. So y has to be greater than or equal to 6. Or y has to be less than 0. Those are the two situations. If I were to write this out in interval notation, well, actually, let me graph it first, and then we'll write it in interval notation. That's sometimes easier. So here's my number line. I've got to have 0 on my number line. I've got to have 6 on my number line. I've got y is greater than or equal to 6, so these values, or y is less than 0, so these values. So a lot of values satisfy this disjunction. Any number that's less than 0 or any number greater than or equal to 6, all those would satisfy this disjunction. Good way to write this then in interval notation would be to say all the values from negative infinity up to 0, but not including 0, or all the values from 6, including 6, to positive infinity. All right, so that's the solution to number 2. And the solution to number 4 here, we want to solve these individually. This is an AND statement. So when I solve the left-hand inequality, I'm going to add y to both sides and subtract 2 from both sides. and then divide by 3. I'm not dividing by a negative number, so I'm not going to flip that inequality. And add 2 to both sides, divide by 2. Okay, so now I can graph this. Much more restrictive because it's an AND statement. So my values have to be greater than 1 while simultaneously being less than 4. So that's where I'll find the solutions to this conjunction. And a way to write this in interval notation would be to say all the values between 1 and 4, which kind of looks like coordinates. When we write it this way, there are certain situations where it's going to kind of look like coordinates. I know, though, from the context of the problem that you're not giving me the 0.14. You're writing a solution to a conjunction in interval notation. So I'd encourage you to do the other two, and then that will help you as you get on to the homework.